We've all been there, right? You have this beautiful, pristine 4K 60 source,
Hmm.
and you're just trying to get it to a display across the facility. And what happens?
Mm.
You're fighting signal loss, compression artifacts.
Or just a black screen. It's that classic bandwidth versus distance problem. Copper just gives up the ghost pretty quickly when you start pushing 18 gigs a second.
Which brings us to what we're looking at today, the Kramer MC3-2F-2F. It's a 4K 60 fiber optic card.
The 2-input, 2-output card.
And looking at the specs, it feels like this isn't just about extending a signal. It's more like they're trying to make distance irrelevant in these big AV setups.
That's a really good way to put it. It's a modular card, so it slides into a bigger switching system. But instead of the usual limits you see with, HD-based or IP streams, it's all about using fiber to keep that raw quality.
And when we say quality, we're not talking about like streaming service 4K.
Right.
The spec sheet highlights 4K 60 4.4.4 support.
Yeah, and that is a huge deal.
It means no color compromise, no chroma subsampling.
Exactly. Most long-distance solutions, they have to drop you down to 4.2.0 to save bandwidth, which can be a disaster for things like medical imaging or high-end signage where color is critical. This card keeps all that color data intact. Plus, it's passing through Dolby True HD and DTS HD audio. You're not sacrificing the sound either.
So it's basically a completely transparent pipe for the signal. But the thing that really made me do a double take was the range. I mean, we're used to fighting for every single meter with copper.
Oh, yeah.
But this is just on another level. The docs say typical multi-mode fiber gets you about 3 kilometers.
Which is roughly 1.8 miles. I mean, that alone covers most university campuses or stadium complexes without any trouble.
But then you get to the single mode capability.
This is the game changer.
If you're running on OS1 infrastructure, the range jumps to 33 kilometers.
33.
That's over 20 miles.
Yeah, over 20 miles. Think about that. You're moving uncompressed 18 gigabit per second video across an entire city. And because it's optical, they're talking near zero latency.
Right. You don't have that processing lag you'd get from encoding and decoding over a network.
Exactly. It makes a display 20 miles away feel like it's plugged directly into the server in the room with you.
Okay, but that distance, that brings up a pretty big logistical question for me. If my screen is 20 miles away, I can't exactly walk over to troubleshoot a handshake issue.
You've hit on why the control features here are just as important as the video itself. This card includes bidirectional RS-232 extension.
Okay, so it's not a one-way street.
Not at all. You can send commands back and forth. You can sit in a central control room and manage all those endpoints remotely.
And what about those handshake problems you mentioned? The eat-it headaches, where the source and the display just won't talk to each other.
So Kramer uses something they call IED Pro. It's basically an intelligent algorithm that just handles all that ED data for you.
So it's truly plug and play.
It ensures the devices lock on right away. No more manual fiddling.
That is critical when your hardware is spread out over that kind of area. I also want to ask about the multi-drop signal distribution. To me, that sounds like a massive infrastructure saver.
It absolutely is. Because you're dealing with light, you can use simple optical splitters.
So one transmitter on this card can feed multiple displays.
Yep. Just by splitting the beam of light. This means you don't need a whole rack full of hot, power-hungry distribution amplifiers just to duplicate a signal.
You're replacing active electronics with passive pieces of glass.
Right. It dramatically simplifies the physical layer of your network.
So to sum it up, we have a card that delivers uncompressed cinema-grade 4K over 20 miles with zero latency and allows for remote control and passive signal splitting.
It essentially decouples your control room from your venue. You could run a live event in a stadium from a centralized hub 3 towns over.
That really forces us to rethink the whole concept of local infrastructure, doesn't it? If the video is uncompressed and instant, then local is just wherever the fiber happens to reach.
It completely redefines the boundaries of what a facility is.
Really fascinating stuff. It'll be interesting to see how this changes decentralized campus and city designs moving forward. That's it for this deep dive. Thanks for listening.